Hi, I'm Israel, and in this video I will cover several interesting topics related to the OpenShift Kubernetes distribution, like cluster administration, user and service account management, continuous integration, deployment strategies, monitoring, scripting, and automation. I have already started the cluster. This cluster has 4 nodes, one master node, one infrastructure node, and 2 compute nodes. Also, have Podman integrated into the cluster to push Docker images. Other tools that are also integrated into the cluster are this WinNFSD server that contains information about a database that will be used later by a Node.js application, and also this HTTP client that it is trying to connect to the Node.js application service, but right now that service it is not available. That is the reason for the status 503 that it is receiving. So let's start with cluster and user administration. I have configured two identity providers here, the HTPassWD provider and the OpenLDAP provider. Now I am going to access using the HTTP PassWD provider and access the cluster as the hypersmell78 user. This user has a limited access to cluster resources, can only access to those 5 projects, and also other resources, for instance, service account, roles, role bindings, and resource quotas. So let's log out and then log in again, but this time using the OpenLDAP identity provider. And this time I am going to log in as the admin user. This user has access to all of the cluster projects and other resources like nodes. Here we can see the cluster nodes and also custom resource definition. So let's log out. Now let's close that window, and now I am going to log into the OpenShift web console, and this time I am going to use the hypersmell78 user. So let's log in, and now I am going to access the monitor project. Here I am going to deploy Datadog agents. I am going to run a script that I have here that will deploy 2 Datadog agents and 1 Datadog cluster agent. Those agents will send information to this Datadog web console. Here I am in the processes section waiting for the information that I can get from the Datadog agents. Okay, after some time we can see the information we got from the Datadog agents about processes. We can see the total CPU used by process in percent. Also the resident set size memory that it is also used. Let's click on one process, for instance, and we can see information about the resource metric. We can also see information about containers that are running in a cluster. We can also see its metrics, container images, and information about the Kubernetes cluster. As you may know, OpenShift is based on Kubernetes. So we can also get information about pods, information about clusters, the cluster we have. This is the OKD cluster, namespaces, the information about nodes. So the 4 nodes I have in the cluster. Let's go, for instance, to network and services. Let's select this Datadog cluster agent service, and we also get information about the network traffic. So that will cover Datadog monitoring. I am going to delete the Datadog agents by running this script. With this, I'm going to delete the agents from the monitor projects. And let's continue with the DevOps project. In this DevOps project, I am going to run a script that will create 3 new resources: a Jenkins server that will connect to an Apache Subversion to get information about source code repository, and with that information, we'll use Builda to build Docker image and deploy resources on OpenShift clusters. So let's wait for the resources to be ready. Okay, let's go to Jenkins. Okay, I have 2 pipelines here. The enterprise Node.js pipeline, that it is declarative pipeline that will deploy resources on my OKD cluster, and the OKD 3.11 sandbox that will deploy resources on this remote OpenShift cluster. This is the OpenShift sandbox. Okay, so I'm going to start with the OKD 3.11 sandbox pipeline. This is an idempotent pipeline. That means that it doesn't matter how many times I run this pipeline, all of those resources we are saying here will be created every time. It doesn't matter if I delete resources, if I delete application, if I delete resource dependencies or any other resource the pipeline will create. So here I have an open LDAP that have information about users, user credentials. I have 2 databases here. I have a .NET application. I have also an API cast proxy and a React application. The React and .NET application are created from the source code of these 2 repositories, the .NET and React. So I'm going to access to the React application and I'm going to log in as the admin user. Okay, if I go to post, we can see 2 posts. The first one was created by this user, the Hypers user. I'm going to the user administration page and I am going to delete the Hypers user. Okay, if I go back to post, we can see that the first post was deleted. So I'm going to restore that information. Okay, so I'm going to log out and let's go to this typology and let's do things interesting. I am going to delete the backend application. And also we'll scale down the MongoDB path. So when I run the pipeline, it will scale up the MongoDB database. It will create the backend application and will restore the database and directory service information. So let's run the pipeline. I'm going to use this parameter here and let's wait for the pipeline to start. Let's wait for a while. If I try to log in again, we can because the backend was deleted, so the frontend cannot connect with the backend. Okay, the MongoDB microservice was scaled up. The .NET application from backend was also created, and the API cast proxy. So let's wait for the database and directory servers information restore process. Here we can see it is restoring database information. Now it's restoring the directory service information. Let's go to pipeline to see if it is finished. Okay, if I go again to the front end, I'm going to log in. If I go to post, we can see that all of the posts were restored. If I go to users, the user was also restored. So I am going to log out, and now I am going to use the second pipeline. This pipeline will deploy a Node.js application using deployment strategies. For the Canary deployment strategy, it will deploy two pods that contains version 1 of the application and one second pod that contains version 2 of the application. That second pod is the Canary version of the application. So I am going to execute the pipeline and go to the enterprise namespace. Here, the pods will be deployed, and let's open the client because it will receive responses, and also the WinNFSD server will process mounting requests. So let's wait for a while here. Okay, the pods were deployed, the WinNFSD server received the mounting request, and as we can see here, the client is now receiving responses. So I am going to stop the client here. As you can see, sometimes I receive version 2, sometimes I receive version 1. This data information I am highlighting. It is the information that the backend gets from a database, and this is the host that processes the request. So in this Canary deployment, we are going to receive more responses about the version 1 of the application than the version 2 of the application, because two of those pods contains version 1, and the service that it is connecting to those pods use load balancing. So that is the reason we get more version 1 than version 2. Now I am going to the monitor namespace, monitor project, and I am going to deploy a service mesh that contains Grafana, Prometheus, and Error Manager to monitor request made to the Node.js pods. So I am going to create this service mesh. This service mesh uses ephemeral storage. So every time I delete the pods, the information that containers create will be deleted also. So I am going to the overview. Okay, now the pods are running. Let's open Grafana. Let's log in as the admin user. This Grafana is already configured with a dashboard. And if you can see here, this is the version 12 of Grafana. If I go to dashboard, let's open this dashboard. And here we have the information we can get from the Node.js application pods. Now, related to this graphic or this dashboard we are saying here, starting by the upper left, we can see request total by version. That is basically the information Prometheus is getting when the client is sending requests to the application. So for the green bar here is the version 1 of the application, and the yellow bar is the version 2 of the application. Now in the upper right side, we can see request total by version, right? So, but in this graphic, we see the total by endpoints. So if we go here to the enterprise project, we have 3 pods. Every pod has an endpoint. So that is the reason we are saying here 3 endpoints. Now, for the gauge in the downside, starting by the down left one, we can see the CPU usage in percent for version 1 and version 2, and the memory usage in megabytes for version 1 and version 2. We can see that, for instance, for the version 2, we have 16 megabytes of memory used, and for version 1, 39 megabytes. That makes sense because if you see here, we have 2 pods that contains version 1 and 1 pod that contains version 2. So that is the reason we can see metrics this way, the same way for the CPU usage. Now, I am going to run the pipeline, but this time I am going to do rollout deployment strategy. So what the pipeline will do is to remove the previous deployment strategy, I mean the canary deployment, so it will remove this pod and will replace the version 1 that it is running by those two pods by two new pods that contains version 2 of the application. Important thing here is that the client will not receive downtimes. So the client here will receive response. It doesn't matter if it is removing a deployment strategy or is implementing a new deployment strategy, the client will receive response always. So I am going to run the pipeline and let's wait here. Okay, the rollout deployment strategy is implementing now. Let's wait a moment for the deployment strategy to be implemented. Okay, it is implemented now. If I am going to stop the client, we can see that we are only receiving version 2 of the application, right, in responses. I am going to stop the client, and the client is going to do request every 100 milliseconds. So in 1 second, the client will do 10 requests. Let's run the client this way, and I am going to run the pipeline by using the rollout again. So basically what it will be done is to do a rollback to the previous version, in this case version 1. So let's wait for a moment. We can see that the client always receives responses. In the meantime, the deployment strategy is implemented. So let's wait for a moment. Okay, I am going to stop the client here. As you can see now, the version that the client is receiving, the version of the application is version 1, right? So I am going to stop the client and configure for make request every second. Now I am going to use another deployment strategy, for instance, blue-green route. The blue-green route basically will do a patch to the route that it is interacting with the service. So if I go to the route detail, we can see that the service that the route is using is Node. Now I am going to do this deployment, and I am going to the overview of the enterprise project and wait for the deployment strategy. So a new application was created. This node green we can see on the bottom side of the screen, and now we can see that the route now is pointing to the node green service. If I go again to the application, let's go to routes, we can see that the service now is the node green. That was another service that was deployed along with the deployment strategy. So I am going to do another deployment, but this time the AB 70% traffic routing for A and 30% routing for B. So I am going to use this strategy. The pipeline will remove the previous node green deployment strategy and will apply the AB deployment strategy. So let's wait for a moment here. Okay, we can see that there is new information related to the traffic here. It says that the traffic is split by 70% for the node service and 30% to the node B service, right? Now, let's do a deployment of blue-green by service. So in this case, let's go again to service, and when the blue-green is applied, there will be a node green service here, and the node service will redirect the traffic to the pod that contains the version 2 of the application. So let's run the pipeline. Let's go to the overview, let's open the client, and let's wait for the deployment strategy to be implemented. Okay, now we can see that we are receiving only version 2 of the application. Now let's run the pipeline again, but using the A/B deployment strategy, but this time 30% of traffic redirected for A and 70% traffic redirected for B. I am going to execute the pipeline. Let's go again to the enterprise namespace. Let's open the client and wait for the deployment strategy implementation. Okay, now in the traffic split information, we can see that for the node, traffic is redirected by 30%, and for node B, traffic is redirected by 70%. If we go again to Grafana, we can see all of the information that Prometheus got from the Node.js application. Now I am going to open Slack because I have configured Prometheus to send alerts when there are no applications in the enterprise namespace or Node.js application. So I'm going to open Slack. Let's wait for a moment. And I am going to run a script that will scale down the Node.js application pods. So we'll see here that the pods are scaled down. Let's wait for a moment. Let's open Slack. If we go to client, we can see that it is receiving the not available status. And yeah, as you can see here, we receive the alert manager notification. Okay, if we go to Grafana, we can see that there is no traffic or request made to pods because were deleted. And yeah, that's all. Hope you enjoyed this video. Thanks for watching.